Good morning. I have a kind of a feeling in my gut that quite a few people are probably still downstairs. But welcome. We want to start on time because today is a fully packed day on what appears to be a very interesting topic. UKTIN seems to have been hitting a particular nerve on certain areas on the activities that the UKTIN as a project is doing, and one of those is this the AI, unleashing the power of telecoms through the AI, and other key technology advances. The one of the hero events that we call sort of large events that the UKTIN is organizing. My name is Dretan Kaleshi. I'm Director of Technology for 5G and digital infrastructure at Digital Catapult, and also one of the founders of the UKTIN, together with a few people in the room like Dimitra and Bob, and Peter is not here, and a few other people that are not here with us today. I will be emceeing today, and so you'll see more of me later on, but I wanted to effectively start with a bit of an introduction on UKTIN, and more specifically on the future capabilities, telecoms future capabilities activity that UKTIN is running. First of all, UKTIN has been launched in March 2023. It was a competitively won project by the 4 members of the consortia, and it started in October 2022, and it is now a fully established brand and name and project activity across the UK ecosystem. Our vision and our mission is listed there, but fundamentally we want it to effectively be able to bring together the UK telecommunication ecosystem, understanding and reflecting and being very, very active parts of that ecosystem, that telecoms is going through a very, very fundamental change, the kind of change that happens once in a generation, every 30 years, mid-90s to now, and probably setting itself up as a sector for meeting needs in a completely changed society in the future. And as a telecom sector in the UK in particular, and with a characteristic that is probably a bit more unique in the UK than the rest of Europe and potentially the world, it is a sector that it is characterized by a very active participation from the different stakeholders in the ecosystem. It is highly competitive in all aspects of the ecosystem, from industry to operators to academia. It is also highly collaborative within individual subsectors of the telecoms. So the 4 partners got together back in March 2022 and said that it would be good to try to shape a UK telecommunication innovation network for the future, and the 4 partners are listed there. The project is led by Digital Catapult, because we play a key role in the telecommunication ecosystem, and we have a critical capability we have built over the past 8 years in terms of a Center of Excellence for Telecoms Innovation. University of Bristol is a world leader in telecommunication systems and advanced technologies related to networking. West Midlands 5G, with their particular regional capabilities, skills, and the innovation space in cities, as well as Cambridge Wireless, as one of the best-known names in wireless industry and more broadly in the telecommunication industry in the UK. We expanded way beyond the original UK 5G, which many of you are familiar with, which operated as a network of networks to disseminate and bring the ecosystem together, to effectively look into more specific activities to fulfill the front door and the signposting function that the government expected out of this competitive bid. And that's why the partners work together across a number of different activities, from ecosystem communication, part of which is what is happening today, from capability discovery that is led by University of Bristol, understanding who is doing what where in the UK, in the telecommunication systems, supplier specialist guidance, acting as an inward signposting and directing service for industry in the R&D ecosystem in the UK. The future capability telecoms coordination activity, that it is led by Digital Catapult together with University of Bristol. We are undertaking some activities in standards and in adoption, but also we are very, very clearly focused on helping in particular towards future capabilities on research translation in the telecommunication ecosystem, as well as for innovation translation, as well as looking into the skills, regionality, and social value. And it looks like there is a large amount of money. It isn't. It really isn't. But there has been a tremendous amount of work that has been done, and I'm speaking on behalf of all of the partners in the project and in the consortia. And this is a research snapshot that our leadership team put together, which shows the breadth of the activities. However, today's event will be focusing primarily on the future capabilities coordination activity that the UKTIN is undertaking. And I will be speaking a bit more specifically on that by way of introducing also the rest of the today's event. So it is not a surprise, over the past 7 years, telecommunications has been a particular focus from the government. It is one of the 5 strategic important areas in science and technology, together with AI, quantum, semiconductors, and engineering biology. And the UK wireless infrastructure I've pulled out of that particular excerpt, which specifically talks about 6G, but immediately expands the 6G into the full telecoms ecosystem. And it is that particular end-to-end view of the telecommunication ecosystem that the UKTIN has been trying to target with the specific work that we have been doing in establishing a long-living consultative structure for getting the community views, the ecosystem views, the telecommunication views, in an open and impartial way into the government and to the rest of the ecosystem. Something that, to be frank, hasn't existed for at least the past 30 years in the UK. And the reason for why we set this particular ambition when we set this piece of work up, and it was one of the most discussed pieces of work 2 years ago, is because the telecommunication R&D ecosystem overall in the UK is very, very fragmented. And sometimes this fragmentation is reflected in the fragmentation of interventions. You'll see a bit being done on semiconductors, and a bit being done on space, and a bit being done on wireless, and a bit being done on optical comms, when all of that effectively come together into potentially what is, not potentially, but what is an industrial sector. It is well known, and it is evidentiary based, that the UK academic R&D in telecoms is strong to world leading across all areas in telecoms. Whilst we also know that the industrial telecoms R&D, with some notable exceptions, some of which are in the room, but the telecoms R&D, not just in wireless, but specifically in wireless, has been in decline for the past 15 years for various reasons. We also face, which is primarily a geopolitical kind of a reflection, that the extreme market-driven approach to telecoms R&D may lead to outcomes that over a long period of time are not necessarily aligned with national strategic objectives. So this is a space where the ecosystem and the market-driven approaches, which are primary forces that move innovation forward, how can we vectorize and coalesce some of them together in order to also align them with national strategic objectives? And also, again, because of the reasons listed above, it is not programmatic enough across the telecommunication industry sector as a whole. It's not long-term enough. That we see very, very often fire and forget consultations and structures. There is no continuation. There is almost no so what, and in 2 years later, certain recommendations that were followed. What did happen with those? What was the outcome? This, in particular in R&D, has been compensated to a very, very large extent by the very, very strong and often leading participation of the UK R&D in European programmatic work. That space at this moment, it is probably changing now that we are again, and it is a very, very welcome change, part of the European funding and European collaboration scene. But that structure needs to be driven also by the UK. So, in order to address some of these challenges, we set ourselves up with 2 objectives 2 years ago, and I'm very, very glad to say today that we have achieved those objectives. Number 1 is to provide an open, inclusive, and an impartial critical mass ecosystem. It's a very long list of words, but each one very selective, very consciously chosen and implemented to get an ecosystem-driven roadmap of the UK telecommunication capability development looking forward to 2025-2035. There is a lot of consultations happening, both open and mostly closed. But we wanted to effectively have an open consultation with published papers that effectively present the position of a consultative critical mass of the ecosystem into the rest of the UK. The second objective, which was an ambition, but we have managed to effectively realize, is to establish in UKTIN a long-lived consultation structure that can provide a signposting and a memory-full process of the recommendations, the interventions, and what needs to happen in the future. And the outputs of this is through subject matter expert future capability papers, which you'll hear today from 2 of the expert working groups, one by Yue on the AI and the other one by Simon Saunders on the wireless network, as well as the other 6 expert working groups. And you have many of the working group members here. At the same time, we want to provide a harmonized level. So individuals expert working group are providing individual input. If we are looking at the telecoms ecosystem as a sector, probably how do we address that fragmentation? And we have a specific structure. The structure we put together as an idea for about a year and a half ago is this one. And today we are de facto launching it. It is already operational. That diagram has 160 people of the ecosystem, some of the best well-known experts in the field, all of whom you'll find in the UKTIN website, and many of them are in the room today. They are the people that make this kind of structure effectively work. They are the people that are presenting their independent views, and they are the people that have put a lot of work over the past 6 to 8 months and are ready today to effectively present some of the findings on the AI and the wireless network, and progressively on the rest of the ecosystem. So we have 12 working groups, but some of those are on the adoption. The ones I'm talking today specifically are 8 on future capabilities R&D, 160 people with an amazing engagement. I am, both personally and on behalf of the UKTIN, immensely grateful and at awe for the contribution, the input, and the very active participation in this. This is not working groups. Paul will testify to that, David and other people here. This is really a genuine participation. It is not someone holding the pen and other people reviewing it every 6 months and saying, yeah, it does make sense. It is genuinely people that have contributed sections and own part of those documents. All of this effectively will go into the government and into the ecosystem and provide a common view. And what we will consider a success is if you here together and the rest of the ecosystem, number 1, find yourself represented by the views on those papers. I'm confident that you will. And second, take an inspiration for trying to vectorize some of the intervention and some of the work that people are doing in individual areas and find partners and collaboration to effectively come into an overall telecom ecosystem. So this is the list, the whole list of the groups and the chairs. The groups are set up to be independent. So UKTIN asks the questions, but we don't provide the answers. Of course, it's painful for some of us, which I would very much like to be on the other side of the fence. But I am really grateful for the other people doing the work for this time. And you can see, and please find the people in the working groups and the chairs that are here today to provide you with further input. This is a bit of a timeline. 4 of the working groups have finished their white papers. They are under review. They will be published during February. So the AI and the wireless network, we anticipate that they will be published before the third week of February. There is some minor, but the work has been completed. Each one of the paper contains very specific recommendations, and you'll hear directly from the working groups very extensive recommendations across a multitude of areas, from skills to research and development and interventions in between. And I want to stop here and say quite a very, very brief words by way of introduction also to you. The structure of the day is to disseminate some of the activities that UKTIN is doing specifically on the future capabilities, but also to represent and to use the networking here to ask for your continuing engagement. Beyond those core expert working groups, there is a wealth of expertise. Also, I'm sure, I was going to say I hope, but I am absolutely sure, a lot of interest from people that are working at the forefront of these technologies, both in industry and in academia, to effectively take these things forward. So without further ado, this is what UKTIN has been doing. We are launching this structure. It is established, it is functioning, and it is functioning better than we actually dreamed. So I think, Dimitra, that's a very, very confident statement coming from me. People that know me know that I don't usually go out on a limb. At this moment, and without further ado, to effectively put the focus back to the people that have actually been doing the thinking and the work on the individual sub-technology areas in the AI and others, I want to invite Dr. Yue Wang to effectively give the keynote on the latest research on UKTIN on the AI Expert Working Group. And Yue, please introduce yourself. Thank you very much.
Yeah, thank you, UKTIN. Good morning. It's a real pleasure to be here today and to share with you the findings from UKTIN AIEWG on the future of AI in telecommunications. So the AIEWG has 15 members. We are supported by one brilliant secretariat, who is sitting right there. So over the past 8 months, we have had 8 very productive meetings, countless discussions, and that has led to a 77-page report on the opportunities and challenges of AI in telecommunication. Well, I would like to thank the astonishing amount of coffee that went into the report. I would also like to thank the group members who have devoted their time, their energy, their expertise generously into this report. So the purpose of this presentation really is, first of all, I would like to share the views from the EWG. Obviously, we have discussed, examined, and debated all these views among ourselves and with the internal and external experts extensively, but nobody can predict the future. And when it comes to AI, it's hard not to have a debate. So the second purpose is really to bounce off some of these views with a wider audience, such as yourself. So it's a 70-page report with lots of details, but I think eventually it boils down to these 3 fundamental questions that we would like to answer in this report. Now, first of all, what role does AI play in telecom? And then what are the impacts in the next 5 to 10 years? And finally, given these impacts, how do we want to go from there? So 3 simple questions, but with no simple answers. So what role does AI play in telecom? Well, AI is a foundation for telecom transformation. Over the past few years, we have observed the network is getting more and more complex, and the network OPEX and CAPEX are increasing day by day. At the same time, there is a reduced revenue. Over the past 5 years, the average return on investment was less than 1%. So telecom desperately need a transformation, and that comes from reducing the cost and also expanding the new revenue stream. So on expanding the new revenue stream, this is a so-called telecom to techco journey, in the sense that the telecommunication companies, in addition to enhance their existing services such as connectivity, they would also look to expand the new revenue stream by providing the AI-empowered, value-added services to the third party, so become a technology company, techco. And we should emphasize this is not just for the benefit of telco industry. I mean, there are numerous examples where AI can benefit telco, which we'll discuss a bit later. But at the same time, it is equally important to realize that the telecom network as a platform is also a significant catalyst for the advancement and the widespread adoption of AI. And we should also look beyond just the commercial gains. I mean, over the past 10 years, a few decades actually, the telecom infrastructure has been innovated substantially to provide with us better and better and better services to the customers, to the enterprises. There is more than just the commercial drive behind it. There is also this drive to provide with us the better connected future, for example, in the healthcare sector or in the education sector. So this transformation is important, not just for the telecom industry, but also for the other sectors, for the business in the other sectors, for the economy, and so for the society. So this is how important that role AI is playing in the telecom transformation. So in the report, we have identified, actually the industry has identified in the past few years about the application of AI in the telecom network. These are listed in the report with a lot of detail. I'm not going to touch on the details of the use case today, but just to give you a quick example, and I like to use this example all the time, that according to an operator, there are 12 million run parameters that needs to be configured every month in their network. So it's becoming increasingly impossible to operate a network without intelligence and automation. Not to mention when it comes to 6G, there's increased the traffic, increased the number of users, and increased the need to support a lot more use cases that are posing much more challenging requirements to the network. But we figured it all out, we have those good use cases, we put them into the network, some at the early stages, some is already deployed, is already providing benefit, but it's still far from the vision of full transformation. So the reason I'm saying this is because these are good use cases, but the true value of AI is to transform the network from the operation to the services and to the business as a whole. So in other words, I can't have this fully autonomous service provision if my 12 million run parameters are still manually configured. So that has to happen as a whole, and that brings a significant impact across a number of aspects, including the technology, including how we build the partnership and business models, and how we drive innovation. So across the EWG, again, we have identified a list of topics that are impacted by AI. We studied them one by one in very detail. I would definitely not have time to cover any of these topics in detail. Please do have a read of the report when it is out. What I'll do is I'll pick up some general themes. I'll talk about the impact, but more importantly, I wanted to show you why we recommended what we recommended in the paper. And the first one is AI native. Well, I think AI native is going to be so fundamental and so significant that it's going to impact from how we might want to run and design the network to how the network might need to be tested and the services to be provided, all the way up to how we might want to address the AI solutions differently in the network. So when we say AI native, in the simplest term, it means AI everywhere in the network, widespread in the network. We are not just talking about plugging or embedding a few AI models here and there in the network. It is a network that supports a large number of AI models in the core, in the UE, in the different locations, different domains, different components of the network. And again, from operation to the services and to the business. So when the AI application becomes this widespread in the network, we do need to figure out how they can work together, work interactively and collaboratively, and to address multiple use cases simultaneously, rather than just address each and every use case isolated and individually. And that might change how we might test the network and test the AI solutions in the network. Because even if I have a perfect AI model that is designed and tested again and again and again against a particular use case, it doesn't necessarily mean it will work well with the other AI present. So in another word, how do I make sure, all these AI modules, they are trained by different vendors using different data set in different environment will behave as expected when they are deployed in the network, knowing that AI is pretty much a black box at the moment. And that might impact how we address the AI solutions in the network. So I was in a London Tech Week the other day, and William Webb made a very good point about the fragmentation in the regulation. But I think that relates to how we address AI solutions in the network at the moment. So what we do in the network at the moment is we look at the network, right? And we'd be like, oh, you know what? I can use AI to enhance traffic steering. Yeah, what do? I build an AI model. It's a piece of software. I put it in the network. I build a patch to the network, right? And then I build another one, and then I build another one. And then I look at the network and be like, oh, you know what? Those two patches, they don't work well with each other. They conflict with each other. What do? We build another patch on top of it. Yeah, so this fragmented and this piecemeal solution is making the network really, really complex, and it's getting increasingly complex. So that also reflected how we address innovation at the moment. So just think how many research projects out there are looking at building that perfect AI model for a particular use case without considering the overall impact to the system. And how much effort are fragmented, repetitive, and are reinventing the wheels from sourcing the data to sourcing the computational resources to developing, validating, and deploying the AI modules. How nice it would be if we actually have a unified framework, common tools and platforms, and to help us develop, validate, and deploy the AI modules to help us overcome the initial barriers on the data, on the computational resources, and to avoid our fragmentation and also to reduce the cost of integration for the different AI solutions at a later stage. So I would like you to hold on that thought on the unified framework and common tools and platforms, because we'll get back to it a bit later. Now, a few words on infrastructure. In a conventional network, you would have, for example, the run, the core, the network management software building on top of it. That is the infrastructure, building blocks for the infrastructure. When AI is implemented in the network, you would have a network as a platform that supports data, intelligence, communication, and computational resources. So now, in addition to the communication resources, you would also have the connected computational platforms, such as CPU, GPU, storage, the servers, the data centers, and edge cloud. And they need to be worked orchestrated by the network flexibly in order to accomplish the computational tasks, such as training and running of the AI models. At the moment, a lot of training happens at the cloud, right? You would have the centralized server, you would have the AI accelerator to perform the training, or in general, the computational tasks. But we do observe there is a significant trend where the computational tasks are moving closer to the data source, for example, to the edge and far edge equipment. Well, this helps to reduce the latency, it helps to enhance the privacy, it also helps to reduce the data passage among the network. So one good example here is if I actually have a run AI model that I need to train it at the cloud, I need to pass all the run parameters, run KPIs, run environments to the cloud, which is a heavy burden to the already restricted computational communication resources and to the traffic. And we do think there's a significant role where the semiconductors can play here, because while the big companies are developing this powerful AI accelerators for the computational intensive tasks, there is also opportunity to optimize the compute and to accommodate this low power and low cost AI, for example, at the edge, at far edge, and even at the device side. And then there's something really interesting on hyperscaler. So at the moment, we are relying heavily on the hyperscalers provided by US companies, for example, Google, AWS, Microsoft. It's not entirely a bad thing because it helps you to avoid this upfront investment, and then you can focus on the real innovation without needing to worry about the maintaining and building the infrastructure. But it does potentially expose sensitive data and advanced research result to the foreign cloud. I mean, you can argue it can be kept locally. There is GDPR, but there is definitely a potential risk and the data privacy and security concerns. And we don't have too much control of that platform, which means, if one day the service is disrupted, then there is not much we can do about it. It is very encouraging, though, to see the UK government is investing in the high-performance computing centers, such as the Parallel Computing Center in Edinburgh and the more recent one in Bristol. And we do think it is a very good move in the sense that it does not only fill the technology gap, but more importantly, it also helps us to seize the opportunities that AI will bring. But we just need to make sure that computing center is keeping pace with the acceleration of the GPU development, because the center is built with the most recent available GPU, but the hyperscalers actually routinely update their GPU. And there is this really interesting article that is recommended to me by Mr. Dave Happy from the Economics from June last year. And it compares the capability of AI in the UK compared to the other regions. Very interesting read, highly recommend. And then data. I think we're all very aware of the challenges around data. Getting data is so difficult. There is always GDPR privacy security concerns. And even if we do get data, they can be incomplete, they can be unstructured, unlabeled, and then you spend a lot of time, efforts trying to processing the data and making sense of data. Now, data fragmentation is another issue here because while the network has an abundant source of data, for example, from billing, from services to the network functions around the core, the transport, edge cloud, but they are still they are also kind of stored and processed differently in the network. For example, they can be stored in the logs, in the legacy systems, in the data repository, and a spreadsheet in a local computer. So this fragmentation has made the data sharing and the exposure of the data really, really difficult. There are standard activities that are addressing it, but we actually have multiple standard activities addressing it. And having that multiple standard activity actually reflects the fact that there is this fragmentation. And then on top of it, there is ethics, security, privacy concerns. Regulation is not particularly certain when it comes to, for example, passing the telco data across the globe. So all this issue adding together has made data that formidable challenge for AI innovation. And I would say it's the first challenge for AI development, and second being the computational resources. It would have been much more efficient if we actually have a unified data framework that can help us to streamline the data process, the acquisition of the data, management of the data, maintenance of the data, and to help us overcome the initial barriers for data in the innovation. And we should emphasize this is not just for the benefit of the telecom operators, although operators do spend quite a lot of resources, maintaining the data, getting the data. So being able to sharing that data would have been more cost effective. But more importantly, it is also about catalyst this thriving ecosystem around data. There are lots of debate around it because if you expose your data might contain commercial sensitive information, private information, and you need to have the mature business model, you need to have the standard APIs, and you need to have, more importantly, the trustworthiness among all the entities, right? So if I'm going to share my data, I need to know who owns the data, to whom it is sharing to, and under what protocol that data is used. So lots of debate around whether this data exposure and monetization of the data is actually feasible, but it's very encouraging to see there is actually already such a framework in Europe, which is called Gaia X framework. They have 377 members across all the different sectors, telecom for sure, and then education, healthcare, agriculture, manufacturing, finance, and they are working together to drive the European data economy of tomorrow, and that's their mission. We do think there's a real opportunity in the UK where we can do something similar, to build this Gaia X framework and to help catalyze this ecosystem around data. And that leads to our first recommendation. Actually, it's a third in the paper, but it's a good time point to introduce it here. It's on the unified data access. So the recommendation is about initiative to create the unified data accessibility towards a goal of safely opening the network data and facilitating the data sharing in the UK telecommunication ecosystem. So the emphasis here is about catalyze the thriving ecosystem, leveraging the telecom data, provided if there is a strong and secure data governance framework. And before I introduce the last recommendation, which is pretty much my last slide, I would like to say a few words about innovation, because there are so rich opportunities for innovation when it comes to telecom AI, from data annotation to the accept development to the provision of the AI-driven, data-driven services to the third party and as a third party. Just think of the ChatGPT App Store style-like innovation, but mapped to telecom. But it does need us to have a bit of agile and fresh thinking. I know it sounds cliche, but we have stayed in this industry for such a long time. We are so used to this 10 years 3GPP cycle, one generation after another. But AI doesn't work that way. Just look how fast it took Gen AI to fly. So that sort of adaptation and evolvement of the telecom mindset is much needed for keeping pace with the acceleration of AI. And finally, we do think there is real opportunities to transform the R&D outcomes into the commercial viable, scalable solutions. But again, it needs us to be a bit more coherent and systematic thinking, rather than just based on the piecemeal, fragmented solutions. So remember what I said at the beginning about unified framework, common tools and platforms, and that leads to our first recommendation in the paper, and I think it's the most important recommendation in the paper, which is about future network platforms. And the recommendation is to create a future network platform and the innovation program to co-innovate, co-develop the AI transformative capabilities in the future telecom with the stakeholders. It helps to boost the innovation for all the reasons I mentioned today across the presentation. It helps to develop the ecosystem because it's co-developed with the stakeholders. It helps to upscale and rescale the workforces because it can be used as a training platform. It helps to enhance collaboration because it's a common platform to co-innovate. And with that note, I would encourage you to please have a read of the paper. There are other recommendations in the paper. There are a lot of details on the different various of topics in the paper. So please do have a read of the paper and have a read of this summary slide, which is pretty much what I talked about today on the impact of AI into telecom technology partnership and business and innovation. And finally, this is my most important slide today. These are the people in this EWG, and thank you to everyone who has made the excellent contribution to this paper. And I'll stop here. Thank you.